Today's sponsor is Datadog, a real-time monitoring platform that unifies metrics, logs, and distributed traces from your cloud containers and orchestration software. Datadog's container-centric monitoring features allow you to track the health and performance of your dynamic container environment. The Container Map provides a bird's-eye view of your container fleet, and the Live Container View searches, groups, and filters your containers with any criteria, like tags, pods, or workspaces. To start monitoring your container clusters, sign up for a free trial today, and Datadog will send you a free t-shirt. Visit datadog.com/container-cloudcast to get started. That's datadog.com/container-cloudcast.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We're coming to you live from our massive Cloudcast studios here in Raleigh, North Carolina. And it is Aaron, and I am back from KubeCon. A couple quick announcements, and then we'll get right into our interview. But I will say this, this is one I've been really looking forward to for quite some time. We've been looking to get a show specifically about vector databases, and we got in touch with the folks over at Chroma, so we have that coming up soon. But a couple quick announcements. Number one, how was KubeCon? It was good. Here's probably the biggest both compliment and maybe backhanded compliment all at the same time I can give to the CNCF and KubeCon. It was a great show, just like all the other shows. And maybe that is good. We've really reached, I'll say, steady state for KubeCon and the Cloud Native Con. And impressive show, like the facility. Chicago actually wasn't too cold, wasn't too rainy. So, hey, overall, it was a good show and met a lot of really good folks and had some great conversations. The other thing I would add as another announcement, thank you again to everyone for all your feedback. We have received a number of it, and Brian and I have been talking about some ways to potentially modify the show and the format in the future, and we're going to have more on that soon. But please, if you do have feedback about the show, let us know. show@thecloudcast.net. So with that, I'm going to wrap up announcements. And as I mentioned, coming up right after the break, we're going to be talking to Jeff Huber, co-founder and CEO over at Chroma, and all about vector databases.
Are you getting pressure from finance to justify or reduce your cloud bill? CloudZero is the only cloud cost platform loved by engineers and trusted by finance. CloudZero can identify unused, idle, or over-provisioned resources, alert you to spend anomalies, and organize 100% of your spend into a framework that mirrors your business structure, like cost per customer, product feature, or team. It's the most powerful platform ever built to provide accurate, granular visibility into your total cloud spend without the typical pitfalls of legacy cloud cost management tools like endless tagging or clunky Kubernetes support. Manage cost, optimize development, and maximize profit, all in one platform. Join companies like Rapid7, Drift, and SeatGeek by visiting cloudzero.com/cloudcast to get started. That's cloudzero.com/cloudcast. Visit today to experience immediate and ongoing savings on your cloud bill.
And we're back. And this week for a topic is something a lot of folks have been asking about. And as Brian and I have been digging more into AI, it's really something we've been needing to cover because it's a foundational technology here. And so we're going to be talking about vector databases today. And so to talk about that, we actually have Jeff Huber, co-founder and CEO at Chroma. So first of all, Jeff, welcome to the show.
Thanks for having me, Aaron. Excited to chat.
Absolutely. So tell everyone a little bit about your background and what brought you to create Chroma.
Yeah, so I've worked in applied AI for many years. My co-founder and I think, saw how challenging it was to build applied AI systems. It's just kind of a whole different beast than building software with only code. These new primitives are really powerful, but they require different strategies and tactics and techniques to get them to production. And I had experienced that pain firsthand. And so, the reason that we started Chroma was we wanted to make it easier for developers to build and deploy AI systems. Since February, we launched the open source vector database that is Chroma, that's known and now loved for by millions of developers. And it's been quite a journey, quite the honor. And I think we're only in really the first barely the first inning. Maybe it's the first pitch of kind of all of this stuff, but also true about Chroma's journey.
Yeah, and it's funny you say that because, we often use the analogy of, hey, it's early innings or it's the first inning, but I've never heard anybody actually use it's the first pitch in the inning. So that's, absolutely. That's where we are.
Yep.
So Jeff, our audience, like many out there, we're learning AI as fast as we can. So let's start off with maybe a few basic concepts. What is a vector database and why is it so important to AI?
Yeah, you think about these new primitives, these new large language models, and more broadly, large models. Now you're seeing some multimodal models come down the pipe, things that can both fluently speak in English, but also fluently speak in images or video or other modalities, kind of like the human brain can in some sense. These are really powerful tools. We still need the ability to either teach them things or guide their behavior, give them instructions on what we'd like them to do. And the reality is that, no one system can both learn all things perfectly and execute all tasks perfectly. And, for many applications, perfect or near perfect is really important. And so typically the way people come into this, like the simplest explanation is that people have used ChatGPT and they're like, oh, this is like really cool. It's a very powerful tool. But wouldn't it be nice if it, quote, knew about my data? If it knew about my internal HR knowledge wiki base, or if it knew about all the specifics of, Star Wars fan fiction, or if it, knew about my email, right? And the way to bridge the gap between these private data sets or specific data sets and AI is through a vector database. So exactly how the tool that a vector database brings here is the ability to do fuzzy searching. This allows us to take the intent from the user, which is typically in the prompt. So let's say a user asks the question to this, chat AI, what is my company's time off policy? We want to then find supporting information that will help the AI synthesize and provide an answer to that user. The AI has not memorized your company's time off policy, so we need to provide it that information. But we need to go and search for it. We need to go and search underlying documents and figure out what is the right information to ground the reply or response from the LLM. And so obviously in this particular case, the user asks the question about a time off policy, but maybe we don't have any mention of that exact string inside of our documents. But we'd love to match against things like holiday policy for the European folks out there or vacation policy for us Americans. And the beauty about the fuzzy search capabilities of embedding space is though these concepts use different words, they are conceptually similar. And so their vector representation will be close to each other in vector space. And so when we query the user's query about time off policy, and we ask to retrieve relevant information, we will find those documents using the power of fuzzy search. And so this is a microcosm, I think, of what will be the case in the future. But this is the Retrieval-Augmented Generation workflow, or the RAG workflow, as many people have called it, that has become incredibly popular this year. And it's a technique, again, to be able to, in some sense, teach the AI, provide the right information in a just-in-time way to AI so that it can be helpful.
And Jeff, so that's fantastic. Thank you. And you mentioned RAG as well. So Retrieval-Augmented Generation, is it possible without a vector database, or is anytime you're talking about RAG, you're basically pairing it with a vector database? What's the technologies look like behind the scenes?
Yeah, if you're using RAG, you're always using a vector database. RAG is I think, a term that has been helpful to help educate developers and other folks on this kind of broad technology and why it's helpful today. I think that RAG in some sense is still very small-minded, and there's a lot of stuff coming down the pipe, which is going to kind of blow people's minds. And today we think of Retrieval-Augmented Generation RAG as a sort of one-way door. We bring in our documents, we stuff them in the database, and then it's done. And there's no kind of dynamic process there. There's no updating that happens. You're not reifying and improving the documents inside the database. It's just kind of a one and done. And all of those things will change in the future. But I think it's, helpful today to have a somewhat simplified analogy to help folks kind of, get their feet wet.
And So when it comes to getting information in the database, let's talk about that for a second. So like in your example, go looking up vacations, right? Is this you're dumping a bunch of links into a database? Is it you're dumping a bunch of documents into a database? And how, does it have to be trained or tagged, or how does all of that work to go from a link to, say, an embedding in a vector database?
Yeah, that's a good question. So I think the beauty of embedding models is that they are, in many ways, very, very closely related to language models. And so language models have been trained on, the internet scale of data. And these embedding models have been as well. So there's a lot of now general purpose, both closed source as well as open source embedding models that work really well for many, many, many applications. And so, you may not need to have your own embedding model or a specific embedding model for your domain-specific task. And specifically, what gets embedded kind of depends on the embedding model. So some embedding models can do text, and so you pass in a paragraph of English language, let's say, and then it gets embedded, and that means it gets turned into a number. Like literally gets turned into a list or an array of numbers, and that array of numbers represents a point in space, and that point in space represents, the vibe or the essence of that paragraph of text. So if you have a link, you need to figure out, okay, well, how do we scrape the relevant information? What information do I think is relevant from this link? Maybe it's paragraphs, maybe it's also imagery. How do I embed all of that? Or how do I break that into pieces? And then how do I embed all of it? And so developers who are building applications will have heard terms like chunking, which is the task of, taking a long document and dividing it into pieces to be embedded. And then, of course, they'll have heard the term of embedding, which is, taking now each chunk and passing it through an embedding model. So hopefully that's helpful.
Fantastic. And so let's talk about how this helps those foundational models or large language models that are out there. But I think we need to also distinguish between there are models that are out there that are closed, like say OpenAI and with ChatGPT, and or models that are out there that are open, like say MetaLlama 2 or Falcon or MPT or something like that. So first of all, is that correct to think about that in like an open and closed philosophy? And then how does vector databases really help these foundational models, like when it comes to integrating into them? Does that make sense?
Yeah. So the way that a vector database interfaces with a language model is through the context window. And so the beauty of embedding models, language models, and vector databases is that they are entirely composable and pluggable together. So you can use Chroma with any embedding model, and you can use Chroma with any language model. Now, obviously, you bring up the sort of open and closed source conversation on the language model side, sort of also on the embedding model side, I guess. Obviously, the closed source models to date have received, have both been A, the most impressive, and has also received B, the most attention. Open source models have, in comparison, been very popular amongst, specific subgroups and communities, right? You mentioned Llama 2, the Falcon model. Recently, in my peer group, a lot of people have been excited about the Mistral models. And again, we're in the earliest days of this stuff. So all that stuff is yet to be played out, and exactly what will be the case 3 years from now is anyone's guess. But Chroma as a vector database plugs equally well into all of these tools because again, the interface is just the context window, and so there's no extra machinery or surgery or integration required. It just works.
Fantastic. And so, what are some of the? Let's kind of talk trade-offs, right? Because I do kind of step back for a think of it. Like say you take Mistral for instance, right? You're taking a model the models are getting smaller, the models are getting better. But there is kind of two ways you can really get your specific data in, and that's fine-tuning, or basically adding the data into the model and training that model with that data, or RAG and a vector database, and that's the concept of keeping it external. So if it's not in the model, it's going to go do a lookup, for lack of a better term, into the vector database. Mm-hmm. What are the trade-offs between fine-tuning and RAG, and how can folks kind of make that decision and better understand why you would do one versus the other?
Yeah, I mean, the answer is not either or. And so I think that's the first thing to say. These are different tools and they serve different purposes. And in different scenarios or contexts, one or both may be appropriate. So to kind of break down this 2x2, right, of retrieval, no retrieval, fine-tuning, no fine-tuning, right? That would be the 2x2. Let's start with no fine-tuning and no retrieval. So this is just like pure vanilla ChatGPT. So
Sure.
maybe you say like, okay, transpose this table for me, or rewrite this paragraph and make it sound happy. You'd write that these tasks, in some sense, don't require fine tuning or retrieval. They can just do it purely in the language model directly. I think today, for fine tuning only and no retrieval, the use case that I've seen thus far primarily is sort of character AIs. So, a personality, right? Oh, you want to chat with Han Solo or something like this. The use case for no fine tuning and retrieval today primarily is, applications where you want to ground the model in some facts. Trying to get the model to remember factual information via fine tuning is kind of a fool's errand. It is incredibly difficult. And so it's a much better idea to use retrieval for those sorts of use cases. And this is, I think, the majority of like sort of practical or business applications today. I think 80 or 90% of them should be doing this today, at least no fine tuning, but yes, retrieval. The last bucket is fine tuning and retrieval. And my mental model for how to think about fine tuning and retrieval is, in fine tuning, you're teaching the model how to think. And retrieval, you're teaching the model what to think. And so in some scenarios where you've moved beyond the kind of domain-specific language of generic English, and you really need the model to learn a new ease, if you will, so like a doctorese or lawyerese, in some ways, this is a different way of thinking. In those specific scenarios today, at least, I think fine-tuning is probably a good idea, and retrieval is almost certainly also very important and necessary for those sorts of applications. Now, I will quickly say that I think this is today's state. And so fine-tuning today is not incredibly popular or powerful, but I think that in the future, actually the majority of applications that are using language models or other kinds of multimodal models will want to use fine-tuning. And the reason is because you will want to be able to take advantage of models that are smaller and cheaper to run. But to get models that are smaller and cheaper to run in production, you probably will need to fine-tune them versus the models that are larger, slower, more costly. You might be able to get away with not fine-tuning them. So I just wanted to give the audience that context that today, the majority of use cases do not require fine-tuning, but do require retrieval. I think in the future, more and more, it'll be a both story. But again, these tools do different things. And so it's never like, should I do one or the other? It kind of depends on the context, which or both are right for you.
Yeah, that's fantastic. And thank you for that. That's really insightful. And I never really thought about that, what to think and how to think model. So that's super, super helpful. Now, let me ask you this. Use cases today, like run everyone through, like you're talking about, talk about, say, the RAG model with no fine tuning, right? Where 80 to 90% of organizations are probably in that bucket today. What are some of the most common use cases you're seeing for Chroma and vector databases?
Yeah, there's lots of different ways, obviously, to kind of fragment what a use case landscape looks like. I think, one of the ways that we've been thinking about it is like, what is the modality and like, how does it work? So the current version of chatbot call and response. So, human says something, AI says something. Human says something, AI says something. That ability to kind of chat your data or chat your documents, incredibly powerful, incredibly popular. I think that like probably, one could argue that, I don't know, at least 25% of like, well, maybe not that high. Maybe 15% of the world's companies now have built, large companies have built some small, at least proof of concept in this direction. And many of them are rapidly, pursuing production experiences as well. So this chat your data use case with this kind of call and response over a language model, very cool. There's the opposite end of the spectrum, which people typically use the term agents. And so instead of you human kind of saying something and then the AI just saying something and back and forth, it's the AI kind of operating on its own as an agent and doing things for you and talking to other agents. And you've probably seen some experiments like this earlier this year with kind of almost a virtual world of agents, right? Doing things on your behalf and communicating together. I think that is likely something of the future, but is still fairly far off. And then in the middle, there's this hybrid. And so this hybrid state is sort of partially chat your data, but partially agentic. And in this scenario, it's not purely a one-way conversation between you, the human, and the AI, right? You can imagine a world in which the AI, out of the blue, asks you a question and says, not just what is your favorite color, but how do you want to process this email? I don't think that I have a good context yet for how you like to process this kind of email. And so this ability of embedding intelligence into every product and service that we use today, I think is incredibly promising. We're starting to see just like the very, very, very few first use cases and applications here. But I think that, even 6 months to a year from now, we'll wonder how we ever lived without it.
Gotcha. Okay. That's perfect. Thank you. And let's also, let's kind of close this up by actually talking about Chroma. We mentioned it a little bit in the beginning, but I mean, as you mentioned, introduced back in February, and there's the open source project Chroma, but extremely successful. 3 million downloads, 9,500 GitHub stars, if I remember correctly. Yep. Probably inclusion in some 10,000 plus projects, and you had a big milestone here recently as well with over 1 million instances running. Tell everyone a little bit about Chroma and the problems it solves and what makes it so different and why it has caught on so quickly.
Yeah, I mean, the reason we built Chroma was really because we saw that this is going to be a really important tool. And, we had been building out some experiments using retrieval. We had built our own internal tools because we didn't like the shape of anything out there. It didn't fit the AI native use cases that we needed. And so we released Chroma. And we have a very low amount of patience for complicated things. And we wanted to release something that was beautiful, simple, and just did what you needed it to do. And had great developer experience. And that's the thing that Chroma is known for today is, if you want to build something and you don't want to wrangle through the complexities of certain weird cloud deployment configurations, you should just use Chroma. I think that's really speaks to the growth. All the growth this year is organic. There's no marketing team at Chroma. There's no even developer relations team at Chroma. It's just us, the engineers, hopefully building things that people love. And they do seem to love them, and they talk a lot about them. And, that's been a key part of the story. So it's been pretty incredible thus far. We're really thankful to the community for also investing in the project, making it better. We reply to, I think, most Discord messages get replied to in under 30 minutes. GitHub issues get replied to in under a couple hours. We take everything seriously and use every opportunity and interaction as a chance to improve the product. And so the product's gotten really, really battle tested and really refined, right, as a result of the trial by fire that is the real world. And so, yeah, it's been great thus far. Two kind of big things we're working on internally right now. So we're working on a distributed version of Chroma. So this is a cloud native version of Chroma. We'll scale forever in the cloud. We'll enable serverless semantics, which we think that is important both for application developers, but also important for enterprise users. Because there's no reason to be paying to keep all of this stuff in memory at all times. Memory is pretty expensive, as you know. And then we're also working on a hosted version of Chroma. And the reason we're doing hosted, I think, fairly early in some sense in an open source project's lifecycle, we're doing it early because we think that it's really important to have this to serve developers well. Really from the moment we started Chroma, every day we've heard from developers from every channel possible, the question, when hosted? We were sort of reticent to do it. We didn't really want to do it in some sense, but we realized pretty quickly that I think particularly to serve the JavaScript and TypeScript communities well, having this seamless path to, putting what you've built into a cloud environment where you can deploy it and start, testing it against real users in the real world is really important. And of course, some people are happy to spin up an EC2 instance and deploy single node Chroma to it today. And there are many, many, many users that have done that, and it's worked great. But, for a lot of other people, that's just either too much cost, too much complexity, or too much maintenance, frankly, right? Like to have to pay attention to it is a lot of a burden. So anyways, that's some of the reasons that we've chosen to prioritize hosted Chroma, and both distributed and hosted will be coming soon. And we're really excited about that.
Fantastic. And we'll definitely have to follow up with you, Jeff, and have you on a future show once things start moving along. So we certainly appreciate your time.
Yeah, this has been really great. Thanks for the conversation.
Absolutely. So thank you very much for your time, Jeff. And on behalf of Brian and myself, everyone out there, thank you so much for listening. We certainly appreciate it. And if you enjoy the show, certainly give us feedback and if possible, leave us a review wherever you get your podcasts. So for that, I'm going to close out for this week, and we will talk to everyone next week.
Thank you for listening to The Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.